Hello, people. This is Mrs. Wolf coming at you live from my classroom. Today and this week, we're going to be learning about electrical circuits. When you think about electricity, you have to automatically think of a light bulb, right? Because when we learned about how light was created, or not light was created, but electricity was discovered, we get that awesome story about Thomas Jefferson and lightning bolts and kites making the light bulb, right? So what we're going to do today is we're going to get a little bit more in depth onto how electricity works and how when you turn on a light switch, the lights come on above you. So let's get started and talk about some of those different concepts. So what is an electrical circuit? An electrical circuit is that path made between wires that allows electrons to flow through in order to create electricity. Now, if we think back to the things that we've learned previously, we know that conductivity is the ability to conduct electricity. We know that metals typically have this kind of physical property. So when we're talking about this, we have to think back and think about things like copper wire, gold wire. A lot of times we have copper wire. It's kind of a more common metal, and it does conduct electricity really well. So to have an electrical circuit, we have to have a complete path between a source of energy and between what's going to show that electricity, what's going to, light the room up, for example, a light bulb. So that's a pathway. It's an electrical circuit. So a basic circuit has a power source like a battery, and then a device that will use the power, just like I said, like a light bulb, and then those electrical wires that we've got like copper, etc., that will connect those two things. So some examples that you've got the light switch in your house, you've got your garage door opener, you've got your doorbell. Those are all really excellent examples of what we have in terms of electricity. And then when we're talking about an electrical current, and I'd love for you to write this down in your notes for me, an electrical current is the movement of those electricities and those electrons that flows through a circuit to provide power to those devices. So when we're talking about an electrical current flowing, we're going to start at that power source and we're going to go around a pathway. When a wire is connected to the end of a battery, electrons begin to flow from that negative space, because remember, electrons have a negative charge, into that positive space. So make sure, if you can, write down what an electrical current is. Pretty important. So here's where we got into the really good details of why when you turn the light switch on and off, like why is it that you have sometimes the light's on, sometimes the light is off, right? So the open and closed circuits give us this kind of idea. So when we have a closed circuit, which is what we have here, we've got a complete pathway. There's no breaks, there's no openings. So if here I have the two wires connected to my battery, my circuit is closed, so my light will turn on, okay? When you have a closed circuit, there's no empty spaces. An open circuit, there's an opening. And so when you have an open circuit, there's nowhere for this electricity to flow into. And so there, the light doesn't turn on. There's a gap, there's a space. So anytime you have that gap or that space, you have an open circuit, there's an opening, and it means that the electricity isn't going to flow correctly. Please write down both the closed circuit and the open circuit definitions in your notes. Switches. So many circuits have a switch so that you can turn them on or off. Just like I was saying before, when you flip it off, you create an opening in that circuit. And when you flip it on, you close that opening, okay? And that makes the gadget or the device work. So there's two different types of circuits that we're going to talk about together. Notice that both of these are closed circuits. You can see that they're closed because there are no openings in either of these examples of a circuit. So we here have a series circuit where the electricity is going to flow through multiple points, and a parallel circuit where the electricity first flows through one point and then has to flow through a second point. In a series circuit, electricity only has one pathway to follow. It only has to go through one area. All the parts of the series circuit are connected along the same path. So they are all along this circle pathway. There's no different branches or different sections that you have to follow. If you think about this, you can think about this as a roundabout, right? So when you have a roundabout on the road, everything goes along on that circle. If one part of a series is removed and the circuit becomes incomplete or open, the current stops flowing. But if one bulb gets fused, all the bulbs will go off. So if we're looking here, you can see that these lights are on, but they actually should not go on because the circuit is not complete. So the more bulbs that you add to a series circuit, the dimmer the lights will be. This makes sense because the amount of energy you have here is still the same because you have the same battery. However, the amount of energy here is only powering one light. The amount of energy here is now powering two, so there's not as much electricity for each bulb. They have to split that. And then finally, this battery is powering three, and you can see there's not enough power to light them all the way up. Think about this as like a pie, right? At first, when you get home and you're by yourself and you're thinking to yourself, man, Corona's taking a real toll on me. I'm going to eat this pie by myself. If you eat the pie for yourself, you're going to feel super full and probably a little overstuffed. Then if you have a friend come over, you have to share your pie. Ew. Right? So when you share your pie, there's then less pie for you. And then if there's three people, basically your life is less light, less bright, because you have to now share your pie with two other people and there's much less pie for you. So that's how you can think about it. When you have more bulbs in a series, there's less light, there's less energy for that initial bulb, so they have less light together. So we use series circuits in Christmas lights. It's a great example. When one of those Christmas lights turns off, what happens? All the lights after that light that is off will turn the rest off. So that's why you always have to make sure you don't step on a bulb because then you have to replace it. Great things about series circuits, you use less wires and it gives you a warning that one of the parts has failed. So if this guy goes off, this guy will also be off. So you'll know exactly which part of that series is broken because everything after that series is not working. And also you use less wires because there's less pathways. Parallel circuits have multiple pathways or branches to follow and the current can flow through them even if this guy's off. So please make sure you write down the definition of this parallel circuits and the definition of series circuits back in the video. If you have to go back, you can. So here you've got multiple paths. So you've got this path, but you also have this path to flow. So in this example, if my top bulb breaks, my bottom bulb still works. If my bottom bulb breaks, my top bulb still works because there are multiple paths for the electricity to take. So that's a huge advantage of these parallel circuits. It allows for electricity to keep flowing even if one part of the system burns out or breaks. So that's exactly what I said. The light will stay on bright no matter how many, I'm getting ahead of myself so much in this lesson. But so they'll stay on no matter how many bulbs you add. So basically our homes are series circuits. You can also turn off your computer and your TV will still be on. This allows for you to run multiple electrical things at the same time without worrying about the whole system shutting down every time you turn your TV off. And it's useful if you want everything to work even if one thing breaks, which is what I said before. So here's a circuit diagram. So when we're looking at circuits, you have to kind of draw out or map out what you're going to do with them. And the purpose of this is to use symbols to kind of give you an understanding of what each of these things. So scientists and electricians use these diagrams, and electricians, their diagrams are much more complex than this. But for our understanding of electricity, we're just going to use a very simple, we've got the battery, we've got the light. So a battery looks like this, and you can always look back in your notes to see that. A wire is a straight line. A light is like this, and then a switch, it has that opening and closure. Because remember, when you turn a switch on, you close the circuit. When you turn a switch off, you open that circuit and create that gap so that the electricity cannot flow. So we talked a lot about conductors and conductivity during our previous lessons. Conductors are materials that electricity let go flow through. So you can notice a lot of our conductors are metals, copper, iron, steel, silver, but also water is very conductive. People are very conductive, and trees and animals as well. So those living things, they are also pretty good and conductive. So in a light bulb, we have that metal conductivity to help us out. So I have a quick question for you. So why do you think that they tell you to get out of the water when you're swimming and there's a thunderstorm? Well, the lightning is electricity, and guess what? Water's conductive and you're conductive. So guess what's going to happen to that water when it hits that lightning when it hits the water and then hits you? You're going to conduct that electricity through the water and through your body. Insulators are very much the opposite. They don't allow electricity to flow. Great examples are plastic, glass, wood, rubber, and a lot of times they'll wrap wire in insulation so that way you can, keep the electricity in. If you are like me and you roll over your power cords really often, as you can see here, my computer power cord, some of the wires exposed, not safe at all. But that wrapping, that protective wrapping is so that the electricity stays and those connections stay maintained. So that's all I have for you on conductors, insulators, electricity, series and parallel circuits, and open and closed circuits. Please make sure that any of the definitions that you found in this video, you make sure you write down for your own notes and for your own reference. And let me know if you have any questions about this information, and you will then complete a Gizmo lab, which is your assessment grade for this unit. Thank you very much. I'll see you guys later.